Welcome. In this section, we'll be looking at building with AI. We'll be covering some core concepts and strategies that you should consider while building with AI. To jump into this, I just want to talk about these common problems that everyone faces when building with AI. There's so many frameworks, which framework to use, what are the security risks, what are the regulations, high costs, so much information just to filter through, how do you get from POC to production and, get everyone, on board. And then there's testing and consistency. And then most importantly, managing expectations and just keeping all that in one go. And it might just feel there's just so much going on. How do you even start? Well, we want to try to tackle that here and just think step by step to get you through building with AI. I just want to tell you a quick story. So, I made a quick POC of an application running on my local, and it worked pretty great. And when we're trying to move it to production, there was a lot of extra complexities I never even thought about. And it started to haunt me, mainly like infrastructure or just tracing like what actually happened and even inconsistent output. So it would work great for one person, but not really great for another. And everyone else has their own different needs, and you have to cater for this. How do you even go about that? Or worse, you get biased feedback. So certain people pull rank and they say this is the direction the app needs to go, and you don't actually take all the relevant feedback and you push it in that one direction, only to verify later that most other users are using it for a different thing, and that just leads to wrong choices and wasted time. And then lastly, sometimes you need to integrate these like AI systems with other systems to either have the permissions to access the different systems. Is the infrastructure in place? And these are just like some of like the problems like I've run into. And hopefully this framework will kind of give you a guide of how to start with this, how to building with AI, and just keep managing expectations and taking the right steps so you can kind of see what's coming down the line. So this is just an idea phase of how you should think about it. So I want to start. What is this presentation for? Well, mainly I want to make sure you avoid common pitfalls that we just discussed. I want to accelerate your AI journey. And lastly, I want to make sure you understand some of the key points while building with AI. So these are the 10 key points to effect. And I actually put here these effects I wish I knew when I started my AI journey. So one is structured outputs. Uh, stop stop over relying on frameworks. Functional approach to AI development. Planning for maintainability. Importance of RAG applications. Evaluations, recall, and precision. Effective prompting. Streaming in AI applications. Gen UI, and from POC to production. All right. So to start off with, what is structured outputs? Well, structured outputs, essentially what the name implies, is you get outputs that are structured, so you can leave it as a JSON object. And this is really handy while you're working with AI, so you can actually get the AI to give you a JSON object back or an XML document back. And with that, you can extract the outputs you want and do different things. So a good example is like if you're doing an email, you can get the name and do different applications with that name if you've extracted from the text that your LLM's like been processing. And the last and most important thing, it's measurable. You can actually expect, you're going to get the structured output back. So you can start like categorizing, does it actually match what I expect? Is the value correct? Yes or no? And that just makes it a lot easier. So we talked about structured, but what does unstructured outputs look like? So this is like your general large language model call. So you can see here on the left, we're doing a call to OpenAI, just asking it to extract personal information. And then on the right, you can see we've got Sarah Johnson, address, occupation, name, all that. That looks quite structured, but sometimes it'll add in unnecessary text at the top. Sometimes it's like, here's extracted personal details. And say if you're building an application now, you have to take that top line or make sure you're building around so you can actually extract only what's needed. Or it might not even put the variable names there. It might not even just go name Sarah. It might just say has the personal details and spit it out there. Sometimes it varies. And this is why structured outputs are so more valuable. So on the left here, you can see in this example, I'm using in the package instructor. This is a Python library. You can do this with any kind of framework, like TypeScript as well. There's a variants TypeScript, they've got Sod, and I personally like Vercel, the Vercel AI SDK. But anyway, jumping back to the example, you can see I'm kind of giving it the object of address, and I'm also telling it the personal info. And you'll see then we're doing the same call, but on the right, we're getting this like structured output with the name, address, the city, occupation, all neatly bundled. And what's great is now we can then just retrieve what components or what information we want from the output. So you can see I can now print just the email, and it'll just print the email straight there. I don't have to do an extract of text to get the email and validate that it's getting to the right text length and all of that in the structured output. It just does that for me. So this just saves us time. It just makes the application a lot more manageable and predictable, you name it. So it's just a great practice to use. Structured outputs just make your life a lot easier, but there is a trade-off. It sometimes takes a bit longer to get a structured output from the large language model because it has to reform its thoughts for a structured model. So some people might only want an unstructured response if they're just doing plain text. So just keep that in mind. But you can just do validation on the inputs and outputs of your function if you're using a large language model. Just try and modularize it that way. And we're going to close this section off now. Okay, the next section is just limitations of frameworks, why you shouldn't over rely on frameworks. So, what are frameworks great for? Well, they're really great for getting started. They handle a lot of the complexity for you, help you develop faster, and also allow you to get, also you can get started without knowing all the steps. So you can build up proof of concepts very quickly and get playing around with a lot of these AI frameworks and tools. What are the negatives? Sometimes they might not offer the flexibility needed for complex applications. So, for example, Origin, like they have a management agent that handles the conversations between different agents, and it sometimes gets quite hard to find out how the context of the memory is being managed, and it's even harder to trace. And these frameworks kind of obscure that from you. And if you do want to try get access to it, it becomes a lot harder. Just to force it the way you want to, you kind of build more complexity into the framework that it's not really designed for. So it can actually hinder you with large scale production due to costs and memory usage. They're also still very early in the maturity, so they might change quite constantly or be affected like drastically. So Origin's a good one. Like the team split up, they've got two different copies, so you might be wondering, okay, which one are we going to be using now for production? And that's just something to take note of. But what are the key considerations if you are deciding to make a framework? Things that you should be aware of when approaching to use a framework. Well, first, frameworks often abstract critical processes. Like I said earlier, that could be like memory management. And sometimes this is essential to understand debugging and optimization. And you might have to work circles just to get into that. Other thing is custom actions in enterprise might not be supported. So you might want some custom functionality within the framework, and the framework might not support that, leading to limitations in functionality or building your own processes and then trying to weigh into the framework. Also, there's inconsistencies from over reliance. So solely relying on frameworks can create a fragmented code base, complicating maintenance and increasing the risk of bugs. So the more dependent you are on a framework, and especially if you use multiple frameworks across your code base, it gets a bit more complicated to maintain going forward. You also will want to confine yourself to that framework because you don't want to adopt too many. So you also might find you only tend to go to one framework and not allowing you to experience other different frameworks that are out there or concepts coming through and deploying to your own solution. So you must choose your frameworks wisely or just contain to certain sections of your application so it becomes manageable. And the last thing is like deployment. So some frameworks don't allow you to do serverless. You won't be able to do it that way. You might have to do everything in a monolith or containerize it into a big EC2 instance, and that might not be what you want. So just keep that in mind when you're really choosing a framework. Go through all these different steps and just think about, does this actually match what your use cases and what you're aiming for? All right. So if you are building with any framework, the main things I think you should always have access to is one is memory management, understanding what data is being passed to and from your LM, and how can you manage the memory more efficiently to reduce costs as application grows. Also, does it allow for flexibility? Can you put in different processes or different workflows? Is it cumbersome to do so? If not, that's probably a great framework. And then logging and error tracing. Can you put good logs in that you can consistently trace what happened within the application and then debug that? And then lastly is like, is it consistent in the code structure? Is it very easy to read? Um, does it allow for quicker development, and is it overly complex to do simple things? I think that's a big one in the frameworks, while keeping true to everything else that we just discussed in the section. And if you can find a framework that works like that for you, I highly recommend you use that. Um, okay, the next part of building effectively with AI is try use functional programming. So try modularize a lot of your code. So it helps make it predictable and easier to test. It also makes the AI code more manageable. Um, and also, the one thing I really like about it is you can, if you actually follow this approach, you can actually use AI to help you with coding because it's contained to that framework. You don't have to test for other scenarios. You're only testing for the use case of the module that you're making. So the way to think about functional programming is like a puzzle. You can start a puzzle with any piece. You can start from the outside and work your way in, or you can start from the middle and work your way out, but it will still all work together. Where a recipe would be more like an iterative approach where you have to follow it step by step to get to the result. And we're seeing with like AI agents, you have to have things a bit more modular so you can call different things at different times. So this is just good practice to, set from day one and move forward. So what's the benefits of, building this way? Well, it's predictable. You got pure functions that produce the same output for every input, which makes it easier to test and debug, and it can reduce some side effects. You can also run these processes in parallel, so it's a natural fit for distributed computing, easier to scale AI training across clusters, and better performance for large data sets. It's modular by nature. Again, we lean back into the debug and testing, can be used for components to build more complex applications later on, and it's just easier to manage. Um, and just the fourth one, like I mentioned earlier, if it is all self-contained, you can use AI to help your code, which will help speed development and testing and things like that. So I highly recommend using this approach. And this brings on to the next point. You have to really think about the importance of maintainable code. It's very easy, with the new AI landscape to write code that is overly complex and a lot of things are happening, but things change rapidly. And if you do not make your code modular and maintainable, you'll be stuck with technical debt wondering what happened. So you really have to make your code more maintainable. So, that just helps with reducing technical debt. Uh, Also helps with people onboarding. So if you've got new people onboarding on your project, you can onboard them faster, segment them to a certain code base and they can work on that, not affecting the rest. It also allows for collaboration because like sometimes you might want to interact with other people working on different functions and that just makes it a lot easier. And it just supports long-term success. So really focusing on maintainable code will set you up in the long run. And again, if you follow the practices that we talked about in this section, it'll set you up for success. Okay, so what are these strategies you can, implement to make sure your code is manageable? Well, one is adopt consistent coding standards. Don't change your coding standards every week. Try establish like coding conventions that are uniform across the code base. So from one section to another, people aren't changing different things. Write comprehensive documentation. I'm going to lean more into this more than ever than I should, but with AI, it's become so important with documentation. And I've actually found that if I document what I'm working on with my AI, I can actually use that process using AI for the following up. So think of documentation not just as a once off, you can actually use it to help your productivity later on. It's not just a useless thing that maybe no one will use. You can actually use it with AI now to actually get you better results that you don't have to manually do it yourself. So I highly recommend using documentation. You can use AI to help you write some of the documentation that when you're building. So highly recommend using building. Sorry. So highly recommend writing documentation for the code that you're doing and the environment. Third, again, modularizing your code. The functional programming aspect that we talked about earlier. Keep that modular. Make it small. Only keep what you need, and have each section modularized so you can work together. Implement versioning control. This is just a no-brainer, like GitHub or Git, just to track different changes, and it helps you also work as a team on a bigger code base. And last, just conduct regular code reviews, make sure the code is actually adhering to all your standards that we've mentioned above, and you should have a much better maintainable code base, which will help you, moving forward. So this brings us on to the next section, the importance of RAG. So I'm not going to go into the full details of RAG here, but I just want to highlight some of the importance of it. That's, for those who don't know what RAG is, that's just how you can take our structured or unstructured data, embed it, put into a vector database. It doesn't even need to be a vector database. It could be other databases, but you can then use large language models to grab this information. So in the example here, we've got a query. So that could be what appointments do I have next week? And I could use embed that query to find what's the similarities for it, and then try find in the vector index to see if I can get that context that matches, then rank it, and then push that context back to the LLM, and then generate an answer. So essentially, just to think of it as AI fetching external data to give context to the LLM. That's what RAG is in a nutshell. And this is extremely important with AI applications more than ever. The quality of your data that you feed to the LLM helps produce better results. We talked about, the 4 pillars, and data was one of them. So the better the data you can give your LLM to generate the better response, the better the result will be. So RAG is just growing in importance. There's a lot of different types, but RAG is that cornerstone, helps you connect to external systems. So why does it matter? It allows you to connect to external data sources, like we mentioned before. It really allows you to build complex applications. So like the appointment center that I was just talking about, hey, what appointments do I have tomorrow? I can use the RAG to grab data sources from all my different databases, and then compile that list and then feed it as a result. We're seeing a bit more of a growing trend for it. And RAG accuracy is just increasing as time goes. The more people need RAG and more enterprise level, the better it is. So, these are the core ones. All right, jumping into the next one, the need for evaluations. So we talked about RAG, and we kind of need evaluations to determine what data we're actually grabbing from the RAG. Is the data even relevant? Does it even match our queries? And they're two different tests for this. We'll jump into the next slide. But evaluations just allow us to evaluate what's the effectiveness of our application or our RAG process. So first, it helps ensure effectiveness, helps with optimization, it facilitates data-driven processes, and then also helps us monitor the progress of our application. So what are the two main evaluations, so mainly for RAG in this context, is recall and precision. So recall is just measures how much relevant if items were retrieved. So you can see the book there on the screen. It's got three ticks, three X's. That'll be a 50% recall rate. It's just the amount of how many data and the points that were given to you, the LLM, how much were actually relevant compared to what wasn't, and what was that accuracy. So you'll find in the industry, many people try to increase the recall percentage a lot more because it's a lot easier to do. Where precision on the right is the amount of data in your database and how much of that relevant data is actually getting retrieved from the database to fed back to the LM for that particular scenario. And this is a lot harder to get right, and it might be very costly to increase this. You will have to really refine your filters, your criteria that actually might make the system slower. So that's why I see a lot of more companies focusing on recall. So that's just one thing to note. And the key for all of this is actually balancing the two, because you don't want to high recall and low precision. You kind of want to best of both. A common measure that people throw out there is the F1 score, and they just try to get a best result with both of these. So it's just definitely something to keep in mind when building with RAG. All right, and this brings us to effective prompting. So we talked about how do you build, at a coding level, how do you structure your API calls to large language models? We talked about, our tools, mainly RAG in this instance, like how to retrieve external data. And now we're talking about prompting. So how do we interact with that large language models? So prompts are more important than ever. It's not a meme anymore. And we did cover a lot more of this in our prompting section, so I won't go too much into detail here. But essentially, prompts are the instructions to the large language model, And you should always think about when you're interacting with a large language model, it's like an intern. They're very capable, but they don't always have the right context. So having the right clear instructions and giving it the right information is highly important for the large language model. So that's why prompting is so important. Tips for crafting. So if you are using the structured outputs, tips for crafting better prompts. So if you are using structured outputs, you can use more descriptive parameter names. Yeah. Uh, uh, just, so if you're tips for craft tips for crafting better prompts. So if you are using parameter names for your structured outputs, make sure the names relate to the information that they are storing. That'll help the LLM generate the right response, which can increase performance by 20%. Use XML tags to differentiate different prompt sections when you're passing information to the LLMs. You can even ask it to give you XML tags back that are relevant. Also, tell the model to think step by step. This has been shown to increase its performance constantly over the last year. So put that for more tedious processes when you want the LM to really think step by step. And again, provide clear instructions, be specific about goals, give it the processes that you want it to follow and why is it doing those processes. And then last, don't over complex the task, keep it quite simple so the LM can process it. The more complex, the less likely it's going to work. So again, on screen, this is just a quick example of a prompt. Be using XML tags to give the product description, and then we're giving it the document information, and then we're telling it to generate examples. Give us example questions, and we're telling it what kind of format we should consider when doing that. And this is generally a good example of a prompt. Now, this brings us to the next section: streaming and AI applications. Not many people talk about this, but it's extremely important. So if you think about when you use ChatGPT, when you ask it some results, it prints it out on screen, and you can actually read while it's still generating. And that might actually take 28 seconds to generate before you get the response, the full response, I should say. And if you're not incorporating streaming, you can make the user wait 28 seconds, and most people aren't that patient. So streaming is very effective to help with user engagement. It also allows for incremental data, delivery, so people can actually read while it's coming, so they actually feel like they're getting the value straight away instead of delayed. So streaming is extremely important in AI applications. But the one thing with streaming, you must understand there's a lot of considerations you have to do around it. You have to one first is error handling, how you're handling your chunks, how you're handling the data management of the stream back to the applications. Is it overloaded? Is it sufficient? Are only giving what's relevant or what's needed? Also, can your architecture handle it? Is your code base built to handle streaming? Is your infrastructure able to handle streaming? All these factors come into in building with streaming, so you definitely have to think about it. But again, streaming is very critical, and you should just make sure you have it in your application to give a better user experience. This brings us on to the next section, generative UI. So again, a little bit like streaming, generative UI allows real-time based user inputs and AI generated outputs to generate a responsive experience. So you can think of it like generating dynamic UI components on screen, which the user can interact with and actually get more use of your AI functions because of the way it's displayed to them and how they can interact with it. It also can show what's happening in your backend. So if you are doing a larger call and doing like an agentic process where you're calling a lot of different agents, you might want to print onto screen what's happening behind the scenes so the user can kind of understand that, hey, it went to this agent, it's doing this now. And that way the person can feel engaged and wait for what's happening and start feeling bored and gets impatient. Loses his patience, I should say. The other one big point about UI that many people don't go into, UI is critically important for getting user feedback. The more you can push people to give you feedback without them giving it willingly. So it might sound kind of bad, but think about it in this way. If you do a search and no one really clicks on the items that you retrieve for them, that's probably a bad query. and you might want to log that information that they didn't use that. They might actually enter a different prompt to get more information, and that's feedback that you can get that will help improve your application over time. You also have to be strategic about where you're putting your UI elements and how you're tracking those changes and interactions. Think about the thumbs up, thumbs down button. Not everyone uses them, so you have to get creative with your feedback. You've probably been on ChatGPT and it pops up with two different boxes and asking which prompt is better. That's another way of dynamically asking users for feedback. So just keep that in mind. So in the next section, we're going to just show you a little bit of like what generative UI might look like. What you'll see is we type in a query saying just we're looking for exercises. That might be too broad, and we'll have our UI will pop up with a selection box of what we want, and we will tick the ones we want, and we'll also put some extra information, and that will then prompt the LM for that information to give us the right result. This is just a simple search engine, but I thought it was really useful to show. So here we going to write exercises, like I said earlier, but that's very broad. So the LLM is going to ask us for some clarification. It's going to give us in this nice format like, hey, do you mean benefits of exercise, nutrition, or what else? And I was like, okay, give me 3 things for this workout routine. And then I'll go retrieve those results from the web of those 3 main topics and then give it to me in a very nice format. And you can also see we're using streaming. And also before even the text came out, the UI was changing, showing the user that there was stuff happening in the background, so they didn't have to get impatient or anything like that. But yeah. All right, this is the last section. How do you get from proof of concept to production? Well, first you have to clearly define your primary objectives for your application, avoid distractions. Um, always maintain what is the main purpose of it. Don't try add too much fluff. Um, Next is to be, obsessive with data. Is the data actually matching what you want? Is it showing the best results? So continuously grab data, clean it, analyze it, and just drive things forward. Task specificity, like also make sure your tasks are very explicit. Don't be very general. Hyper focus on what you're trying to get the algorithm to do. um, this also allows for better testing and evaluations because you know what it should be giving you, and coming back, you don't have to cater for a broad range of things. So that's very important. And say if you are starting off and you don't have users yet, you might want to put some synthetic data in to see what's actually going, through, and if it actually matches at the end what you want. And that's the synthetic data utilization. So you can use large language models to generate a synthetic data set. So you can use, input and output pairs, and then push that through the system and see what's going on, and then get a relative score. And that's super handy. To recap, you know, starting off with structured outputs, this just allows your AI development experience to be a lot easier because it feels more like an API development process, and it allows you to, put better evaluations, testing in place, and it's more standardized and it's modular. Which brings us to the next one, the limitation of frameworks. Don't over rely on frameworks. Try only use frameworks where it's needed. Then always use a functional programming approach. Try modularize applications or processes so you can then use them in different systems to actually build more complex systems. And it just makes it easier to maintain going forward, which leads us to the maintainability of code, where we talked about coding standards, constantly reviewing, and just keeping things modular. We also then touched on the importance of RAG. How do you use how do you get external data to your large language models to get better results that effectively is RAG? Then we talked about the need for evaluations, how you're actually testing your data, how you're actually checking that your large language models are giving you the right data. Then, effective prompts. Are you building great prompts or not? If not, you're not going to get great results. So prompting is not a meme anymore. Then we talked about streaming and AI, how important streaming is, and why you should definitely consider it in your application. Generative UI, are you considering how the UI is interacting with your user? If not, you should. And then lastly, how do you get from proof of concept to production? That's using that synthetic data, really focusing on the data obsession of what your system is producing, and then take baby steps and push it into production. So I hope you enjoyed the section. Again, just final thoughts. Embrace the journey. It's a long road, but you'll enjoy it as you go. prioritize more modularity, and yeah, always just try reach out and share your expertise with other people, and you might learn in return. And then lastly, just enjoy the journey. Thanks for listening.